Example 2, check your progress, says use the relatively frequency distribution above, meaning on the previous page, to determine the percent of subscribers who required less than 25 seconds to download the file. So to do less than 25 seconds, I want you to go back to that chart. From that chart, I want you to add the numbers. Well, from 0 to 5 was 0.6%. From 5 to 10 was 1.7%. From 10 to 15 was 4.3%. From 15 to 20 was 9.2%. So those are, sorry, and then we have to 25, we had to go all the way up to 25. So then I have plus 15.1%. So those should be the percentages from the chart. If you look at the chart that you're adding, I want you to add those together on your calculator right now. I'm ending up with, please double check my math, 30.9%. So that'd be the percent of subscribers. You got to be really careful here with what they want. They want the percent, so give it to them as a percent. The next one here says find the probability, so we're going to be using a decimal, that a subscriber chosen at random will require at least 10 seconds but less than 30 seconds. So go back to that chart and please write down any numbers that you see that are at least 10 but less than 30. I'm seeing from 10 to 15 is 4.3. From 15 to 20 is 9.2. From 20 to 25 is 15.1. And from 25 to 30, I see 19.2. Again, this is looking at the chart on the previous page. When I do this, what percentage am I getting? I'm getting a percentage of 47.8%. Convert that to a decimal by dividing by 100, moving the decimal left to, or using that percentage button on the calculator. You get 0.478. It is a number between 0 and 1. Looks good to me. So that would be our answer as a probability. Okay. So that's when we do frequency distributions using percentages, called a relative frequency distribution. Okay. Let's go in, let's look at what a normal distribution. It says one of the most important statistical distributions of data is known as a normal distribution. This distribution occurs in a variety of applications. So not all things are normal, okay? But let's make sure we understand what normal is. It says types of data that may demonstrate normal distribution include the lengths of leaves on a tree, the weights of a newborn in a hospital, the lengths of time the students trip from home to school over a period of months, the SAT scores of a large group of students, and the lifespans of light bulbs. So we can find normal distributions in certain areas naturally. I can also tell you that normal distributions don't always exist. So what makes something a normal distribution? Let's look at what a normal distribution is and its properties. It says a normal distribution, that's what we're looking at. I'll go ahead and highlight that. A normal distribution forms a bell-shaped curve that is symmetric about a vertical line through the mean of the data. So the mean of the data is the middle. A mean is also the median. So this is the mean. This is the mean. It's also the median because it's in the middle. And it's also the mode because it has the highest frequency. So the mean, median, and the mode are all the same for this data. No matter what measure of central tendency we use, it's the same. So it says every normal distribution has the following properties. The graph is symmetric about the vertical line through the mean of the distributions. So what does symmetric mean? Symmetric means the same amount. So there's 50% below, there's 50% above. And if I go to any point, it's exactly the same. It's like a mirror image right at that mean, okay? So just as much below as above. It says the mean, median, and mode must be equal. The y value of each point on the curve is the percent expressed as a decimal of the data of the corresponding thing. So what we're talking about here is percentages. So we're using a relative frequency distribution, not an actual frequency distribution, a relative, the percentages. And it says areas under the curve that are symmetric about the mean are equal. So what we're really doing is finding the area under the curve. What that amounts to is how many people lie between these scores. Well, that's the exact same thing that we were answering on the previous question. We said what percentage lied between these two values right here. And that's what we're going to be doing for pretty much the rest of this section. It says the total area of the curve is 1. So what does this relate to? Well, 1 is the decimal version, so to say, of the probability. So remember, the highest probability you could have is a 1. A 1 means everything. A 1 in this case, if you're thinking about a percentage, 1 represents 100%. So when they add the area beneath the curve, they're going to get the probability version, the decimal version. All you have to do is multiply that times 100 to get your percent version. Okay? So normal distribution occurs with very specific data sets. Normal distributions occur naturally in large data sets, in weird data sets, such as what's the height of a male. But you got to be more careful because you can't say what's the height of the male in the world. You have to be more specific by region. For instance, what's the height of a male in the United States? Why can't I say what's the height of an adult in the United States? Well, because then there would be a hump where the height of the females, the maximum amount of females are, and a different hump where the maximum amount of males are. So that wouldn't be a normal distribution. So to be a normal distribution, we would have to consider just males in the United States or just females in the United States. We couldn't include countries like China because the average person there is significantly shorter than the average person in the United States. So you have to be more specific to make sure it's normally distributed. So here's the nice thing is we are going to assume from here on out that every single data set we deal with is normally distributed. We don't have to worry about can we use all these rules, because all of these rules that we do from here on out only apply to normally distributed data. So that's the assumption that we're going to make.